can see here, we are using the concepts, whatever I taught here. We can find Vp by following relation. What is this here? Now this is a free body. So velocity of the particle with respect to c plus Vc. So since this is a free body, unconstrained, so the center of rotation will be the center of mass.
Yes, sir.
So Vp bar c means what? Velocity of the particle with respect to c. With respect to c means? With respect to c means what? That means notionally we have stopped the body from translating.
Yes, sir. Yes.
Right? So therefore this becomes the component of velocity which is because of the rotational motion.
Yes, sir. Yes.
And we allow the body to translate, so we add Vc bar. You can see here I am adding this velocity component because of rotation and this velocity component because of translation, and I get Vp.
Yes, sir.
Yes.
Right? Now, as you know, AP. So if you differentiate the velocity with respect to time, then you will get AP, because this is AP, this is A bar P of C AC.
Yes.
Right?
Yes. Yes.
Fine.
Yes.
So now, when C is the center of mass, knowing VC, AC, omega, alpha, RPC, we can find VPC and APC. Okay? So, and hence VP and AP as follows. Okay. Now, I hope you understood this equation here.
Yes, sir.
Yes.
Hello?
Yes. Yes. Yes.
So now, you see, VP with respect to C. VP with respect to C is omega bar cross RP with respect to C.
Yes.
Perpendicular distance to the point. Got it? Hello?
Yes.
Yes. Yes.
Now, if I differentiate this, see, I will make it clear to you. I need this point to you. So, this is the center of mass and this is the particle. So, now this line becomes what? RP with respect to C. R bar of P with respect to C. Got it?
Yes.
Yes. Yes.
Okay?
Yes.
So, this is it. And now this is moving with omega. This is moving with omega. Right? So, therefore, now what is omega bar cross R bar PC?
VC. VPC.
V bar.
Like
V
that.
bar of PC.
Yes. Yes.
Clear?
Yes.
Now all of you aram here. See, now don't start sitting and writing all these equations and all. It is a futile exercise. Because if you start writing the equations, then only in this chapter you will have about 500 equations. And what are you going to do? Your brain cannot by heart all those equations. And this is simple. See, you have to visualize and learn. That's the only way to learn. And if you cannot learn like this, forget it. So there is only way you have to learn. If you are thirsty, the only thing is you have to drink water, or you have to drink something which has lot of water and something else.
Yes.
I said fruit juice then.
Yes.
I said fruit juice. Fruit
Yes.
juice. Fruit juice. It will have water and other things. But whatever it is, to quench the thirst, you can drink water. So this is it. Now, if you differentiate this, this left side term, V bar PC, okay, is equal to omega bar cross R bar PC, then this first term will become what? A bar PC. Hello?
Yes, sir.
Yes. Sir.
Yes.
Now, the differentiation of the second term will be omega bar cross d by dt of R bar PC plus d by dt of omega bar
Yes.
cross R bar PC.
Yes. Yes.
Okay? So, what is this going to be? This is going to be omega bar cross
V bar. V bar.
V bar PC
PC.
plus, what is this going to be? Alpha
Alpha.
bar cross R bar.
Yes. 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 Sir.
Not whole body.
Partial
Body or
I'm saying no, P means what? For particle. This is the
Everywhere
acceleration.
it is cross product.
Everywhere it is cross product. That will continue. See bar. See if this symbol both sides there are vectors, then this should be seen as cross product.
Yes.
But if you use this and both sides there are scalars,
Scale up.
then it is simply a scalar multiplication, not scalar product. Scalar multiplication.
Yes, sir.
Scalar product means then you will have to use dot dot. And again there will be bar bar.
Yes.
Okay, that's it. So this is it. I hope all of you got this.
Yes.
Hello.
Yes, sir. Yes, sir.
Then what is this omega bar cross V bar PC?
Omega square RPC. Omega.
What is this?
Yes.
This is centripetal acceleration,
Yes.
isn't it? So this becomes AR bar, radial component. Correct? And I write this minus because it is inverted. Hello. Plus, what is this? This becomes tangential.
Yes.
Yes, sir.
Did you get it, all of you? Hello.
Yes.
So this is how you will develop the relationship. So therefore now what is this? This is the radial component of particle P. This is the tangential component of particle P. Acceleration I'm telling you.
Yes.
See, we are developing it like this. Okay. Say now this particle's velocity with respect to center is dp with respect to c. Okay. Now, if external force is acting on this body, then this will also accelerate. Okay. And all the points will accelerate, and this will also accelerate.
Yes, sir. Yes.
So, what is the acceleration of that point? Okay. What is the acceleration of that point? So, develop it from this equation. So, acceleration of that point with respect to c will be so and so. Is it clear?
Yes, sir.
See, these are all the things that are happening with the particles. Now you will be slowly going into the dynamics of rigid bodies which of different shapes and sizes and things like that. So don't worry. You have to analyze them at the ground level. To analyze means what? Take this particle and see what happens, etc., etc. Okay, and that is the way you have to analyze it. Okay, don't worry. You will slowly get used to it. We have wonderful time. So we got this equation like this. All right, friends?
Yes, sir.
Yes, sir. Yes, sir. Sir, sir, unconstrained means no force is acting or net force is zero?
See, now you say unconstrained motion. Supposing net force is acting. Assume net force is acting. So if net force is acting, will it be see now see when I am referring to unconstrained here, I also use the word free.
Sir?
I also use the word free.
Okay, yes, sir.
I also use the word free here. Unconstrained. See here, I use the word here. If unconstrained or free.
Yes, sir.
So what does that mean? That means
Yes.
no force is acting.
No force. Yes, sir.
Understand? No. See, the body is. See, please appreciate and understand the meaning here.
Yes,
When I am using the term here in the context here, that means the body is able to freely rotate. Understand? See,
Yes,
supposing it is touching some body or some force is pushing it. No, nothing like that. It is able to freely rotate.
Yes, sir.
That is what I mean.
Yes.
Got it? Right.
And APC equation you wrote minus AR parts. Is it supposed to be minus AR? On the book writing you wrote minus AR.
It is no minus AR bar means see now here if you take alpha bar cross this, alpha bar cross RPC bar. So this is like this. Now omega bar is up, VP bar is like this. Okay, so omega bar VC bar means it will come towards the center, no? है कि नहीं? ओमेगा बार ऐसा है जी, ओमेगा बार ऐसा है और VPC bar is like this. VPC bar is into the board. Omega bar is up. So if you take the cross, if you turn it cross, the screwdriver will go towards me. So towards me, I am taking it as negative. If I am taking RPC bar positive, then this will be negative.
Yes, sir.
Yes, sir.
Okay, and one more action. Okay, I hope this was clear to you, right? Okay. Okay, now do I have time? Okay, I'll just take another. See, somebody is to come. Till they come, I will teach. Okay. Now let us understand this very carefully. We'll understand. See, to summarize whatever I have taught now, it's a mathematical line about which the body of combined translation can be conceived to be pure rotation and detention. It is continuously changing. Now we explore the combined rotation in this. Consider the motion of a rod from the beginning. Okay. Now I'll take this example. Now don't go on reading those things. Okay. Sir, but some students, they're busy reading. This is the problem. Because in spite of my best efforts, some students are still high school students. Okay, this is the best way. But then you will find out methods of opening this.
We can open.
Okay. Now, see, basically, if you keep a rod here, if you keep a rod inclined to a wall, we have already discussed this. There is no friction here, there is no friction here. I said with that example, but supposing there is friction also, then at a given instant of time, this will have velocity VA bar. I think all of you know this. And this will have velocity VB bar. You can see here VB bar. Okay?
Yes.
Now, what you have also got to appreciate here is that, see, if you see this angle theta, as the rod is moving, this angle theta goes on decreasing. Hello?
Yes.
Yes.
And therefore, notionally now, understand? Or not notionally, in reality, this point is only translating. Can you see here? This A point is only translating.
Yes.
But the B point, what is happening to the B point? As far as the B point is concerned, listen. As far as the B point is concerned, it is moving down. So therefore, along the minus jth axis, it is translating. VA point is translating along the ith direction.
Yes.
And at the same time, since theta is changing, I will say that this point B is rotating with respect to this point A.
Yes, sir.
Yes.
Understand? This point is rotating with respect to A. But the instantaneous axis of rotation of this is not B. You have seen in the last class I have shown, I have drawn a vector here and I have drawn a vector here. The instantaneous axis of rotation is that.
Yes.
Please be careful. But what I am trying to tell everyone here is that this point is only translating,
Yes, sir.
and this point is translating as well as it is rotating. But look at the translation of this point. This is in the minus jth direction.
Yes.
And instant axis of rotation is somewhere here. Now you see what we can do now is using whatever we did here, whatever previously we did here. What did we do here? Okay, what did we do here now in the previous case? We said in this particular thing, what we did do here? Okay, we said now in our case now, this particle P happens to be the particle B, and this particle, if you take it as A particle.
Yes, sir.
See, in this example, I have taken center of mass. Okay, so here in this example, I am not taking center of mass. Instead of, see, here I have considered C, and here I will consider point A.
Yes, sir.
And here I considered particle P, here I am considering point B.
Yes,
Clear?
sir. Yes.
Huh. So
Yes, sir.
therefore now the velocity of point B
Yes, sir.
will be equal to the velocity of point A plus the velocity of point B with respect to point A.
Yes. Yes, sir.
Will you appreciate that, all of you?
Yes.
Yes, sir.
Okay,
Yes.
going by the same line.
Yes.
And this, whatever theory we developed now, okay, I am going to use that theory here. That's it. Okay, so for that rod now, okay, okay, I will write the equation like this. Okay, so VB bar will be equal to VA bar plus VB with respect to EA bar.
Yes, sir.
Will you appreciate that, all of you?
Yes, yes,
Yes, sir.
So, say going by the same.
Yes, sir.
So, why I am taking this example is, this equation we did not have to write always with respect to center of mass.
yes, yes.
Yes,
Okay,
sir.
we don't have to write it. Srijan's voice is at last heard. Right, brave boy. See, he is not feeling well, but he is attending the class. And he is not able to speak, so he is keeping quiet. Well, see, all of you should please, there are many wonderful students in this class who have braved all the odds. And here I am having one Namuna here. There was rain, there was cold, okay, there was dark. Still, he has not missed a single class coming and sitting here. Wonderful. So please keep it up. All of you are now grown up. You should be able to take all these rigors. Right. So I can write the equation like this. Okay? Hello.
Yes,
Yes,
yes.
sir. Yes.
Now let's come to this diagram. Okay. So now in this diagram you see if the rod was simply translating, then B and A would have got the same vectors.
Yes.
Now if you say the rod B is only rotating with respect to A, then you will say B with respect to A, right? So the symbol used here BBA, not B bar A. So both are same. Okay. So this will be equal to omega bar cross AB bar, and I am sure one of you will ask me, sir, this omega is with respect to the instantaneous center or something else. So here I am saying omega is what? D theta by dt.
Yes.
Understand? It is d theta by dt. So I am now seeing this theta. The rate at which this theta is increasing, I am writing it as omega. That's it.
Okay. Yes.
Understood? So in that context, theta is changing, so the rod is rotating. That is what we are going to see. See, because we should not get used to something like circular motion. So there omega is there. No, for us omega is d theta by dt. Okay, so d theta by dt. So then I am going to write here omega bar cross AB bar. So we used to write there. So what we used to write for this? BB bar, we used to write there omega bar cross the PC.
PC, yes, sir.
So instead of PC, I have got here AB.
AB, radius.
Yes, yes.
Right.
Yes, sir.
Now here you see. So what I will do to point B is I will add this vector VA bar. You can see here VA bar vector is added, and I will add this vector V bar B of B with respect to A, this vector. So what I will get? I will get this resultant vector.
Yes, yes.
And that
Yes, sir.
resultant vector is the real vector. You can see the rod is translating down.
Yes, sir. Yes, sir.
Yes, sir.
My dear students, okay, you see, all of you must really, be alert, okay. See, indeed, you are seeing this translating, so you must not be the impression that B is only translating.
Yes, sir.
Though it is appearing that, B is simply coming down straight, okay, but at the same time, if you see here, it is only coming straight down. But if you see this point, then it is also rotating.
Rotate. Yes, sir.
Yes, sir.
So therefore, you must understand that VV bar is the resultant of these two. Okay, and that is what is the theory. So a rod which is slipping, this, and you can see as far as this is concerned, this is purely translating.
Yeah, translating. Yes, sir.
This point is
Yes.
purely translating.
Yes, sir.
And
Even if,
yes, please.
even if point A, sir, if you see with respect to B, we can.
Yes, I was coming to that point. Brilliant point. Okay, I am sure you and some students can appreciate that point. Okay, but therefore I did not mention. But of course, I was having that in my mind to tell you that. But anyway, nice. So the same. If you say this is rotating with respect to this, then if you see from this point, this is rotating with respect to this because you know this angle is changing. You can see that.
Yes.
No. But remember, the instantaneous axis of rotation is not this.
Yes.
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 It is here.
Yes, sir.
And that is continuously changing.
Yes, sir.
Correct? Yes. Fine, students. Okay. Anyway, whatever I have told, I am going to summarize here. Right? So PB bar is equal to so and so. So we don't read everything. Whatever I am showing you, only that much. So VB bar is equal to VA bar plus B bar of VA. VBA is equal to omega A bar. So this equation already I wrote it for you.
Yes, sir.
Okay. Now the abstraction here you see whether it is okay. Rotation about an axis in translation of a rigid body can be conceived as well as analyzed as superposition of translation of any of its particles and simultaneous rotation about an axis passing through that particle provided that axis is parallel to the actual one. Okay. So rotation about an axis in the translation of a rigid body can be conceived as well as analyzed as superposition of translatory motion of any of its particles and simultaneous rotation about an axis passing through that particle. That particle here means A.
Yes, sir.
Any other particle means B.
Yes, sir.
Got it? That is what is it.
Yes,
Particle provided that the axis is parallel to the actual one.
Yes.
Yes, sir.
Actual one andre ena?
Yes, sir.
Instantaneous axis of rotation.
Yes, sir.
Okay. So now if you
The parallels of such an
parallel means, see I told you no, instantaneous axis of rotation, man.
Yes, sir.
Instantaneous axis of rotation, where is that instantaneous axis of rotation? That is the actual rotation, man.
Yes, sir.
This one. So this is coming down and this is going here. So this will be the instantaneous axis. And the axis is passing into this. Into or out of this. Understood? So this is the actual one. So this one now is, if you now consider this as the axis, momentary axis of rotation here, as far as analysis is concerned, we are analyzing, then the axis is passing through this point. And this should be parallel to this.
Yes, sir. Yes.
See, these are all like small theorems, which will help us to solve many things. So AA bar, axle, now you see, this is moving down. This point A is not moving with uniform velocity. It is accelerating,
Yes, sir.
right? Because gravitational force is acting on this.
Yes, sir.
Not only gravitational force is acting down, there is reaction.
Normal.
Come on, somebody tell me, why is this accelerating?
No, sir.
Why is this point accelerating? This point B and A. Why is this accelerating? And the acceleration is in this direction.
Yes.
Why? See, come on, apply Newton's law.
Yes, sir.
If the acceleration is in this direction,
Force should be applied.
there should be net force in this direction.
Yes, sir.
Yes. Yes, sir.
Who is giving the net force in that direction? See, you understand that? See, you are all, by this time you should be smart. The weight vector of this rod is acting down, weight vector.
Yes, sir.
Yes.
Then the normal reaction, N1 is in this direction. And since it is touching this wall, there is one more normal that is acting here, N2.
Yes, sir.
So,
Yes,
now
sir.
here this W must be equal to N1.
Ah, sir.
Yes, sir.
Yes, sir.
Because there is no acceleration component in this direction or this direction. So W is equal to N1. That's satisfied.
Yes,
Now this becomes
Yes.
unbalanced force.
Yes, sir.
Yes, sir.
This becomes an unbalanced force, and it is because of this that you have got this acceleration.
Yes, sir. Yes, sir.
Okay.
Yes,
Now you can also look at it the other way. Supposing you take this point and you take the moment of this force about this point. What will be the moment of this force about this point? N2 into this distance.
Yes.
Say this distance small a. So this is trying to rotate it like this. Now here, what is the force here? N1. So what is N1 here? So sorry, here it is N2. Sorry, this is N2. Sorry. W is equal to N2 arrow, correct? So this is N1 into A, and due to this it becomes what? N2 into, supposing this distance is B, this perpendicular distance is B. Now the question is, now N1 into A, if it is equal to N2 into B, then it will not rotate.
Yes.
The ladder will be like this only.
Yes, sir.
Understand?
Yes.
The ladder. But now these two are not equal. Okay? And therefore this is having what? So this is more. So therefore this is causing this to rotate like this. And that is why this theta is reducing.
Yes, sir.
Yes, sir.
Okay, so you see, you start looking at it like this, you get it, and therefore now here you see there is a small correction here. There it is printed as A bar of A. It is actually A bar of B. Hello, can you see here?
Yes.
A bar of B
Yes.
is equal to A bar of A plus A bar of B with respect to A.
Yes.
Okay, then this A bar of B with respect to A is split into A bar of B tangential and A bar of B radial. Okay, and we have converted that into A bar of B is equal to A bar of A plus alpha AB bar plus the normal component omega square R,
Yes, sir.
centripetal force. So I written here minus omega square AB bar. Why minus? Because it is towards. Hello?
Yes. Yes, sir. Yes.
Okay, got it all of you?
Yes, sir. Yes.
So
Yes.
this type
Sir,
of,
and cross bridge.
pardon?
It should be cross bridge.
What should be cross product?
And they have not written.
They are not written. See, they should have written here omega bar cross V bar. Okay, omega
Yes,
bar
yes.
cross V bar, and omega cross V bar there. V bar they have converted into omega R. And both are perpendicular. So sin theta is 1. And this will become, that is they have opened up V bar, man.
Okay.
They have opened up V bar. That's it. Okay, they have opened up V bar. Of course.
Because the N1A is equal to N2B.
N1,
That equation which is just now wrote.
huh.
There N1 is the force which is acting upward, in the upward direction, sir.
I wrote this as, which one is this as N2 I wrote, and this was N1 I wrote.
So the N1 into B.
N1 into A. N1 into A, this distance.
Yes.
This is going to give this term.
Okay.
And N2 into B is going to get this term.
Okay. But both are in opposite direction, so it will have only translator.
No, if both are equal and opposite, then it would have only translator motion.
So
Now it is not.
Translatory motion in which direction, sir? Like, sir, if they both are counterbalanced, so
Then translator motion in this direction.
in that direction. Sir, but weight is at.
That's what, man. I am taking the moment about this point.
Yes, sir.
If I take the moment about this point due to this, moment about this point due to this,
Yes, sir.
okay, and if I equate all those things,
Sir.
okay, so this is going to cause clockwise rotation.
Clockwise rotation.
This is going to cause anti-clockwise rotation.
Yes, sir.
This is going to cause anti-clockwise rotation.
Yes, sir.
Okay, so here you see for this to be in equilibrium.
Yes, sir.
Supposing this has to be in equilibrium. Okay, I'll analyze it.
Sir, then, sir,
Wait,
what,
So if they both are equal, then what?
Wait a minute. I'll better do it properly. Okay, so supposing I say this has to be in equilibrium. I'll say this has to be in equilibrium. Okay, so this I will take it N1, this I will take N2. So if it has to be in equilibrium, then what is it? W must be equal to N3.
then, yes, sir.
Okay, only this. And there is nothing to balance this N2.
Yes, sir.
So they cannot be in equilibrium.
Sir, but 20
So it cannot be in
that
equilibrium.
I understood, sir.
So for this system, there is net force N2 acting. So this will translate. This center of mass of this, center of mass of this will start moving to the right.
Yes, sir. Because of
Will start accelerating to the right because of N2. That is point number 1. Okay, it start moving because it is unbalanced.
Yes,
That is one way to look at it.
yes, sir.
Now look at the moment due to this. What is the moment due to this force? This force into this perpendicular distance.
Yes, sir.
That will cause what? Anti-clockwise rotation.
Anti-clockwise rotation.
And this force into this distance.
Clockwise.
That will cause clockwise rotation.
Yes, sir.
That will cause clockwise rotation. Okay. So now you see this rod now is slipping down.
Yes, sir.
It is slipping at both the points, and it is slipping in this direction.
Yes, sir.
And who is causing this slipping in this direction? This one is causing the slipping. This one is causing that.
Yes, sir.
That's what I'm saying.
Understood.
Okay, that's it.
Yes, sir.
Okay, fine. Fine. Anyways, I hope today we have covered a lot of ground. It is very intense.